Hi, we have a question on problem number 72 on section 6.4, and we wanted to graph this logarithm right here, y equals natural log of x plus 4. So what I'm going to do at the beginning is I'm going to graph the y equals a natural log of x. Now the natural log of x, remember, first of all, logs are the inverses of exponential functions. So they are symmetrical to the line y equals x for the e to the x in this case because the base is e. But logarithms, the basic ones anyway, goes through 2 points. Well, it goes through a lot of points, but 2 points that we always list is the point 10 because all logarithms will go through that unless you shift them. And the other one will go through whatever the base is, comma 1. And since the base on the natural log is e, it'll go through e, comma 1. E is approximately 2.7, so I count 1, 2, and over about 2.7, and then up 1. So I'll have these 2 points every time. And you graph those points with a curve, and remember that the domain of a basic logarithmic function is anything that's positive. So there is a vertical asymptote on the y-axis. So if you put this together with this, and then there's a vertical asymptote there, then it looks this shape. Okay. Now on problem 72, I am trying to graph this one. So this is just a basic transformation 4 units back this way. So you take every one of your points that you have and you go back 4 units to the left. So you get your graph, and so everything gets to go back 4 units, so including the vertical asymptote. So the vertical asymptote is through there. Okay, the 1, 0 will go back 4 units, so it was there, so it'll go back 4 units, 1, 2, 3, 4. So it's now at negative 3, 0. The one that's at e, comma 1 will also go back 4 units. So it was here, and it's going to go back 4 units. 1, 2, 3, 4, which is approximately right there. It's about negative 1.3 or something like that. So if you connect those points, it looks like this. It has that shape. Now, a lot of times, and people don't think it's important, they start bringing everything back 4 units, so they'll know what the transformation does, but they'll forget to move the vertical asymptote back with it. So what they would do is they'll leave this off sometimes. And you really don't want to leave that asymptote off there like that, because what a reader's going to see is that this graph goes back this way. Because you got to remember, sometimes you've got a graph and you don't know what the function is. So if you put that vertical asymptote there, it kind of solidifies that this is a logarithmic function. So you have to make sure you put that there, because otherwise we don't know there's a boundary there, and indeed there is. So lastly, what we're going to do is talk about the domain. And the domain of this is everything bigger than negative 4. So it's to the right of negative 4. So the domain is negative 4 to infinity. The range, there's no limit. The range continually goes down and continually goes up. So the range is negative infinity to infinity. And lastly, I think they asked for the vertical asymptote, and the vertical asymptote is x equals negative 4. And that's it. So it's a pretty simple function. Could be a lot harder than this one. They could have added something at the end. So if they added 2, then this graph would then have to be shifted up after you did this bit here. So it would have to go about 2 units. This would have to go up 2 more units. So, or they could have stretched it. So this is kind of one of the easier ones. It does get a lot more difficult than this. So, but this is problem number 72 on section 6.4.